Hello, class. This is lecture 0 in engineering mechanics, MECH 3599. And excuse me. I thought that I'd go over the syllabus. That's what I usually do in lecture 0 with these online courses. And I ran this online course similar to this for electromagnetic field theory over the summer. And so I've pretty much got this system down, except I'm just hiding the cable. So I thought that I'd go over the syllabus with you for lecture 0 and talk a little bit about the course and the assessment structure and things like that. Let me just make sure. Yep. No, my microphone seems to be working. I've already made some lectures for you. I think I've made about 5 or 6 lectures. So I wanted to get lecture 0 out of the way now that I've got the syllabus all put together. Anyway, let's look at the syllabus. You should all have a copy of the syllabus now that I've sent out to you by email, because I'm going to use email basically to communicate with you, and you're going to send things back to me at my email address, and I'm going to grade them. I'm going to return them to you by email. It just all makes it a lot easier. And I did this with both the electromagnetic field theory course this past summer, as well as the like AC network theory course the prior semester. So let's go over the syllabus. If you look up in the upper left-hand corner, you see that's my name, Dr. Scott Grenquist. That's my office, and that's my phone number. If you do call that number and leave a message, I still, it immediately is transcribed to my email and tells me that I've got a message so that I can click, and I just get the message if you were to leave me a message there. And there's my email address, so pretty easy to figure out where you're supposed to send things and when you want to communicate with me, where you want to communicate with me at. The department office, right underneath that, Thomas Barry is our academic coordinator, and he, would be a person that you want to call for a variety of things dealing with student services and everything. Office hours by appointment. You're going to be contacting me in so many ways. Stay after class, during the times that we meet. That's what's going to happen over the course of this online semester. Course description. This course covers static equilibrium and dynamic motion. So really static and dynamic equilibrium are two things that we're going to be covering in this course. Major components of this course are force vectors, equilibrium of a particle, resultant and internal forces, centroids, centers of gravity, so that's what we're going to be looking at, and then stress and strain. Now, stress and strain, torsion, moments of inertia, and by moments of inertia, that means both area moments of inertia as well as mass moments of inertia is the way I look at it. And when we go through centroids and center of gravity, we'll probably be going through mass moments of inertia. And then when we go through stress, strain, torsion, and then flexure formulas, we're going to be using area moment of inertia. Shearing, of course, that just comes in with mechanics of solids. And you can really see that what this is 3 courses put together. Statics, dynamics, and mechanics of solids. That's a lot to put into one course. So you're really getting an introduction to statics and dynamics, and then you're going to be using, of course, that knowledge when you go into mechanics of solids. But that's about as far as we can go. As you can see there, kinematics of particle, well, that's dynamics. Kinetics of a particle, dynamics. Force, acceleration, work and energy, all statics. Impulse, momentum, dynamics. The course includes labs that correspond to lecture material. I'll do my best. I've put together, one lab on dimensions and units. It's going to be our first lab. We're going to have about 10 labs. And I have to go into Wentworth to videotape some of the labs that we're going to be doing. I'm going to be doing them on the apparatus that's only in Wentworth. So I'll be trying to get those labs done hopefully before the semester starts, so I don't have to go in there when coronavirus is crawling all over the place. But get those things done, even if we have to use some simulations for the various laboratories. It's just this semester. I'm sure that by October 15th, they'll have the vaccines, and by next semester, we'll all be back on campus. That's the plan. So that's the course description. Course goals and objectives. Use Cartesian vector form and free body diagrams, right? So we'll be starting off and using three-dimensional vectors. I've already done lectures for that on the dot product and multiplication of or addition of vectors. So we'll be getting into vectors, but really vectors. You've worked with comparable two-dimensional vectors by working with phasors, right? So you've worked on the complex plane with phasors. Those are the same thing as two-dimensional vectors. All we're doing really in this course is then extending that into finding their components in 3 dimensions rather than 2 dimensions. And that's easy. There's a lot of mathematics that, of course, go along with that and help you to do that. Perform basic functions with vectors. And that's, we're not looking at the del product that you're going to be looking at, and the curl and divergence, which you'll be looking at in electromagnetic field theory. But we're going to be working, figuring out and knowing dot products, cross products, triple products. What are these used for in statics and dynamics, right? Solve resultant force vector problems. Really, those 3 things. And we're going to be doing those in the first month of this course. Calculate and use the centroid in a system. I have no idea really what that means. I had to take these, of course, off the website, so nobody asked me what to put in here. But yes, we'll definitely be calculating centroids and using centroids for a variety of things. That's one of the topical subject areas in both in statics and then later in dynamics too. Analyze motion around a fixed or rotating frame of reference. Sure, of course. That'd be just curvilinear motion, which we're also going to look at in statics and dynamics. So, that's really motion, so we're talking about dynamics. Solve problems involving particles and planar motion. So really, this is an understatement of what you're going to learn throughout the course, and the course description really is a much broader outline of what you're going to be learning, which is statics, dynamics, and mechanics of solids. Some people call it strength of materials. We have a strength of materials lab that I'm going to be working in downstairs for these laboratories, and it's the same thing. Mechanics of solids, strength of materials. Some books are called strength of materials, some are called mechanics of solids. Same difference. All right. Student outcomes, that's just something for our ABET accreditation, so I'll just let that go. And of course, we're going to be working on complex engineering problems. Credit hours 324. Class meeting times. We're going to be meeting Monday and Friday for the 01 section, and we're going to be meeting Monday and Wednesday for the 03 section. So what I'm really going to do is I'm going to meet with you on Mondays. I think that's probably the best thing because, really when you look at the times we're meeting, 8 a.m. to 9:20 p.m. and 9:30 to 10:50, those 2 things that we'll do is we'll probably meet on Monday. Now, why am I saying that? Because you're going to have close to 50 lectures. If you go and look at the Scott Grenquist channel on YouTube, you'll see that for electromagnetic field theory, which was a 303 course, for the lectures, I had close to 50 lectures up there. Now, these lectures weren't 50-minute lectures. They were 30-minute lectures, 35-minute lectures, 38-minute lectures, something like that. And really, if you think about it, part of the class time in class is left to administration and attendance and all that, and handing papers back. And so those lectures are probably, comparable to lectures that I'm giving in class, or at least what would be close to 50-minute lectures that I give in class. However, the way I look at it is you're supposed to have 3 50-minute lectures for 15 weeks. And that's about 45 50-minute lectures. And somewhere around there is what I do for the lectures. It'll be about that, about 45, uh, assuming that, you know, I get through the same percentage of material, which is about 90–95% of the material that I would do in person. That's about what I got through with electromagnetic field theory, and that's about what I think I'll get through here. Actually, I'm going to try to design it that, you know, you can actually learn more if you want to. But we're going to be going through at a good pace to learn basically the introductions to 3 different ones. People have told me, hey, why don't you put material science in there too? You know, you can't squeeze everything in. So I'll refer to some things in material science when we're doing strength of materials, because material science is a strong area that I worked in both undergrad and graduate school. So we'll see how it all goes. You're going to learn a lot about mechanical engineering. That's what this class is, well, mechanical engineering, or statics and dynamics and mechanics of solids, which are the backbone. Could we get into fluid mechanics? Sure, I'd love to do that. Material science, fluid mechanics, why don't I teach you a whole course in a 4-credit-hour class? Can't do it. Can't do it. So we're going to teach you as much as we possibly can. I'm just going to assume for the prerequisites that everybody has the prerequisites, unless I signed you into the course without the prerequisites, and in that case, you know, we'll see how everything goes, and I'm sure it'll go well. Pedagogical approach, teaching strategies, I'll let you guys look over that. Required text, Ferdinand Beer and Johnson, and now they've got Masaryk and Cornwell in there too, and Self. But the point is, I think Beer and Johnson are both dead, as far as I would assume, because I use them. Vector mechanics for engineers, statics and dynamics. Now, you can use the 10th to the 12th edition. I don't really care. They're very much the same. I'm going to send you out problems to do, but I'm also going to send you out as a resource, I'm going to send you out the worked out solutions for those problems that I'm going to have you do. All right. Now you might say, hey, what are you doing? Well, usually what I would do if we were doing this in person is I would have you go to the reference desk at the library and take these out so I could see that everybody was checking and doing stuff and and using the reference desk at the library, which is really one of my, you know, what I want you to do, get into the library. I mean, I used to have seniors that told me, I've been here 4 years, I've never been to the library. How do you do that? Because it's a great resource. So it was one of my ways to get students into the library. However, I can't do that, so I'm going to send this out as a resource. And so you're still, you know, if you look, you'll see on the next page that homework is 15% of your grade. Now I'm going to give you quite a bit of homework, and you're going to have to do it all. I'm going to explain that in a minute, but if I give you the solutions, you're probably saying, well, I'll get 100% on that, so I'll get an A. No, everybody will get 100%, right? Unless people don't hand it in. Unless you don't hand your homework in, you've got the solutions. I've told you, you got to check, you know, your answers against the solutions, make sure you've done it right before you hand it in. How can you not get a perfect score on your home set? So on a curve, of course, that doesn't form a Gaussian curve, it forms a Poisson curve, and the variance and therefore the standard deviation of a Poisson curve is much more narrow than that of a Gaussian curve, which is how I grade the tests and the examinations. Look it up. You know, don't take my word for it. Go out, look up what a variance equation is for a Poisson distribution. Look up what a Poisson distribution is. You know, it's something like I just told you, where everybody almost gets everything right. And so really, if you get everything right, and you hand in all of your homework and you do all of your lab reports and you hand those in and you get 30 out of 30 on all of those, you'll get a B for your homework and for your labs. How can you not get that B? Don't hand a homework in. Don't hand a lab report in. All of a sudden, on the Gaussian, because the standard deviation of a Poisson curve is so narrow, if you were to not hand in a homework, right, and I don't penalize you for handing it in late, so you're going to hand the homeworks in. If you don't hand the homework in, then that B goes to a C. And if you don't hand 2 homeworks in, then that B goes to an F for 15% of your grade. Who would do that? Why don't you hand in all of your homework and skip the midterm exam, because that's worth 15% too. Nobody would do that, would they? Nobody would do that. And none of you are not going to hand your homework and your lab reports in, because you know from this lecture that would be horrible. So you have to do that work. And really, why do I do that with the homework? With the homework, I want you to be very professional. I'll talk about that at the end of the syllabus. And with the lab reports too, you know, we're really trying to increase written communication skills. That's what I'm trying to do anyway. And that's what you're going to do. So let's keep going. So that's the required text. You can get any of those texts. I'm going to use the 10th edition to send you out your problems that you're going to do for your homework. I'm going to send you out scanned in, you know, 3 or 4 pages of homework problems out of the 10th edition, and I'm going to send you out the solutions for those, and then you're going to, you know, do those and hand those in to me. Now, so I don't really mind, because each of the editions are between the 10th and the 12th edition are almost exactly the same. And they only came out like 2 years apart, so 2 or 3 years apart. So I don't really see that you have to spend a lot of money. I know that there are one of those 3 editions that I've got there that there's a free PDF, you know, on the web someplace, I've been told. Of course, I can't point you in that direction because that would be not right. So anyway, resources, you can't really take advantage of the Center for Teaching and Learning. The lab, we're going to do our best. I still haven't put all the labs together. I've got the first lab together on dimensions and units, which is really a paper lab. But then the second lab, you know, I want to start to get in there and use some of the devices at Wentworth. I'll try to do that maybe even tomorrow. Yeah, we'll see. We'll see how I can do. I got to bring all of my, you know, recording equipment and stuff in there to do it with. It makes it much harder. Wentworth attendance policy, I'll let you read over that. Really, it has no bearing in the semester, if it has any bearing at all, anyway. Assignment submitted, late work, you're going to give me your home sets, or you're going to, you know, take a beating in 15 to 30% of your grade, whether it's the home sets or the lab reports. You got to get them all into me. That's just how it works with grading on a curve. There's our tests. Now I've set up all those tests for Monday, and what I'm actually going to do is I'm going to send out the test on Sunday at noon. And then you're going to have to get it back to me by Monday at noon. I'm giving you 24 hours. And, you know, it would be crazy of me to say, don't use the book, because there's no way I can proctor that. And so some people could use the book and just not tell me, because how would I know? I wouldn't know. You would know, but I wouldn't know. And so I'm going to say, go ahead, use the book. The tests are going to be a little bit harder than they probably would be otherwise, and you know, they're take-home tests. But this is the best way that we can do it. And it's not like I can say, hey, everybody show up and turn your video on, because there are some people that, for some reasons, for very good reasons, do not or cannot turn their video on, and so why even do that? I'm going to send you the test. I want you to do the test by yourself. I think I can request that, and I think everybody's honest enough to definitely say that they would do the test themselves. You're going to have like 24 hours to do the test, and you know, and they'll be a little difficult tests, and you're going to, figure out that you don't know some things. But by the end of the course, you're going to know a lot. It's a good course that's going to go over 3 very important areas that you'll find that you'll use, especially when you're working with mechanical engineers out in the real world, in your engineering job, your career, when you get out of Wentworth. Okay, so let's keep going. Those are like I say, test 1, test 2, test 3. I'll be sending those out. Midterm exam, October 19th. I think that I've got to get like my my grades in. If I'm not wrong, it's like October 23rd or something. Let me just check that. October 20th. So when are we having it? October 19th, we're having the mid-semester exam? That may be changed. How can they require us to get our mid-semester? It's not even the mid-semester. But we may have to change that, to I hate to change it to a week earlier, but it may be something like a week earlier. That would also give you, well, we can't, a week earlier is Columbus Day, so it may have to be during that Columbus Day week that we have the mid-semester exam, so that I can get the mid-semester exam graded and then use it for your midterm grade. All right. So although I'm saying that October 19th may not be the midterm exam day, it may be that prior week. All right. We've got that taken care of. Now, on the next page, you can see we're not going to have a project this semester. We're not going to do it. Sometimes I do require a project. We're not going to. It's just too many things to be trying to put together. 3 tests, each worth 10%. Homework labs, 15%. Midterm exam, 15%. Final exam, 25%. And I don't think that's going to change unless this semester somehow dictates that we have to change maybe the homework and lab work going down or something, and midterm and final exam going up. I don't know. But I don't think it's going to change. I think that's what I pretty much do. Important dates: Columbus Day, Veterans Day, Thanksgiving, no class. Last day of class is December 8th. Our last class day, I believe, is December 7th, Pearl Harbor Day. And academic conduct and honesty. Be honest, right? Because, 85% of everything that we do is subconscious. And I mean cognitive thought is subconscious. So don't let your subconscious pay you back for the rest of your life because you've been dishonest. Karma, some people call it karma. My brother calls it the subconscious. Some people, God's will. I don't know. But whatever it is, when you do bad things, you think about it for the long time, and you're like, God, I shouldn't have done that. And that's, being dishonest on tests. And I'm sure you're not going to be that way. The lecture syllabus I'm going to go over, the lecture and the lab syllabus I'm going to go over separately because I'm still putting the lab syllabus sort of together. I'm still trying to find out what type of labs, I can really do and show you and we can do. So I'm not going to go over the lecture syllabus and the lab syllabus. Also in the lecture syllabus, I plan to probably, before we even start, have at least another 15 or so lectures up there. So that'll give me a good idea of where we've gone, where we're going, how far we're going to probably be able to get in the semester. Also on the last page, all lab reports should include a cover page, equipment and component list, which I would probably give you if I'm doing the lab and showing you things, schematic of circuit, that applies to mechanical as well as electrical. Discussion of experiment, results obtained, conclusion from results, significance of conclusion. And the reason that I lay it out this way is that if you were going to write a journal paper or a conference paper, all of those various different sections would really be in there for the research that you were doing, right? So I want to include that here to give you more or less a template that you're going to start to use for the rest of your life as to how to put reports together and make it professional, right? All homework, if you look down at the bottom, should be turned in on Quadrille paper. Quadrille paper is this type of paper. If I haven't had you before, I know some people have had me, some people haven't. Quadrille paper, it's a 1/4 inch. That's why they call it Quadrille. You can't see my lips. I don't know. So yeah, that's Quadrille paper. I wouldn't, buy an engineering notebook because you can go to a dollar store. A lot of dollar stores have Quadrille paper for $1, a whole ream of it for $1. Put that together for when you shoot in your homework, or however you're going to get your homework sent in to me. Most people, it has to be in PDF form because that's the only way I can grade it. I can grade it here. I wish I had a little tablet, but I don't. If I get it in PDF form, maybe I can get a tablet from DTS or whatever. Anyway, I have in the upper right-hand corner your name, so I know whose paper it is. My name. Now that could be down at the bottom. Who cares? Because I want to know that it's my class that you're turning it into. Before I really requested that, sometimes I would get homework that's being turned into another guy's class. I'm like, well, what's this? I can't grade this in my class. It happens, but it never happened after required my name to be on that homework in the upper right-hand corner. So, it's just like a memo. Class name and number, and then the list of the problems being submitted. And what that really does is that allows me to make sure I've got it in the right home set, box. Box all problems, box all answers. That's just something that you want to do to be professional, make it look professional, make this look like you're handing it in to your supervisor at EMC or Raytheon or BAE Systems or Bose, wherever you're going to be working. Start to make it look professional, right? Be the professional engineer. The thing on the bottom here, as far as the letter grades go, I did put in there, and this has all been agreed to at faculty senate and stuff too, that really the numerical definition is the normalized numerical definition. I totally agree with these, by the way. And what I found with the tests that I have done and I have laid up against this is that my Gaussian curve, in fact, this represents a Gaussian curve. My Gaussian curve fits this, and my grading scale and stuff fits this almost exactly. So that this has been very close all the time to what I find for my tests, and that means it's a good test, right? If it fits the standard normal bell-shaped curve with no Cartosity. Cartosity is where the bell-shaped curve leans to one side or leans to the other side. That's Cartosity. Or wait, yeah. Is that Cartosity? No, that's skewedness. So if it leans one way or the other, I think it's skewed. And then Cartosity is if it's out like this or in like this. I better look that up. Look, I know a lot more about probability and statistics than you guys do. Sometimes I forget things. But yes, your grades will be very fair. And I do a lot of assessment, as you can see, midterm and final and homeworks. And that way, you're going to leave this course, which is a very important course for you. The only course that you're really getting in mechanical. And, you're going to, electricals and mechanicals work closer together than, let's say, electricals and chemical engineering. Electrical and mechanical. Think of the Prius. Think of Tesla, right? Think of power systems in generating plants. They're all electromechanical, aren't they? So electrical and mechanical engineers work together, and you're going to be working most likely with them at some point throughout your life. So learn engineering mechanics and statics and dynamics. I'll teach you very well, and you're going to learn some great engineering fundamentals. Okay. I've already got 1 through 5, I think, up there. Start watching the lectures and the Scott Rehnquist channel on YouTube. Just go to YouTube, Scott Rehnquist, go to the channel. There'll be engineering mechanics playlist. Go to the engineering mechanics playlist, and in fact, you're already here because you're watching lecture 0. Of course you are. All right. I'll see you at lecture 1 then.